Voyager 1, a spacecraft no bigger than a car, is quietly drifting through the vast, silent darkness of space, now over 14.5 billion miles from Earth. Launched in 1977, it was only meant to survive for 5 years. Yet, nearly 5 decades later, Voyager remains active, astonishing scientists with its resilience. But recently, something strange has started to happen. It's transmitting puzzling signals, patterns, pulses, and data that defy explanation. Has Voyager stumbled upon something in the void between the stars? Or more unsettling, has something out there discovered Voyager? The Voyager story doesn't begin with rockets, but with a rare cosmic coincidence. In the early 1970s, astronomers realized that an extraordinary planetary alignment was on the horizon. Jupiter, Saturn, Uranus, and Neptune would soon line up in a configuration that happens just once every 175 years. This rare alignment presented a unique opportunity. A spacecraft could use each planet's gravity to slingshot its way from one to the next, making it possible to visit all four in a single mission. NASA seized the moment, designing 2 identical spacecraft tough enough to survive Jupiter's intense radiation, Saturn's mysterious rings, and the long, cold journey through the outer solar system. Thus, the Grand Tour mission was born, later renamed Voyager. These spacecraft were technological marvels of the 1970s. Each probe weighed about 1,800 pounds and carried 11 scientific instruments. They were powered not by solar energy, which would be too weak so far from the sun, but by radioisotope thermoelectric generators, RDG's nuclear batteries that convert heat from decaying plutonium into electricity. Building the Voyagers was a feat of engineering. Every system had to work flawlessly for years, without any chance of repair. Engineers included redundant systems for critical functions and programmed the onboard computers, equipped with just 68 kilobytes of memory, less than a single modern digital photo, to detect and correct their own issues. Voyager 2 launched first on August 20th, 1977, from Cape Canaveral, despite being labeled 2. Its twin, Voyager 1, followed 16 days later, on September 5th, atop a more powerful Titan I rocket. Voyager 1 was on a faster path and soon overtook its sibling, reaching Jupiter and Saturn before it. As the twin probes departed Earth, few could have imagined that one would still be active nearly half a century later, not just for what it discovered, but for what might now be discovering it. Voyager 1's journey through the solar system was nothing short of groundbreaking. After an 18-month voyage, it arrived at Jupiter in March 1979. What it found there rewrote our understanding of the gas giant. From Earth, Jupiter had always appeared as a striped, mysterious sphere with a single red spot. But through Voyager's lens, it became a dynamic world of storms and chaos. The Great Red Spot, a swirling storm scene for centuries, turned out to be massive enough to engulf 3 Earths. The planet's colorful bands were revealed as fierce jet streams and storms moving at hundreds of miles per hour. Even more astonishing were Jupiter's moons. Io, the closest large moon, stunned scientists by displaying active volcanic eruptions, the first ever seen beyond Earth. These volcanoes ejected sulfur compounds that painted Io's surface in vibrant yellows, oranges, and reds, like a cosmic pizza. Then came Europa, a smooth, white moon etched with cracks like a shattered eggshell. Voyager's photos suggested a hidden ocean beneath its icy crust, raising hopes that this alien sea might harbor life, an idea later supported by other missions. Voyager 1 continued on to Saturn, arriving in November 1980. Once again, what appeared simple from Earth revealed itself to be breathtakingly complex. Saturn's majestic rings, which seemed like solid bands through telescopes, turned out to be composed of thousands of delicate ringlets, some braided, some containing mysterious spokes, all shifting and shimmering in a celestial dance. One object in particular drew intense interest: Titan, Saturn's largest moon. Shrouded in a thick atmosphere, Titan was the only known moon with such a feature, sparking scientific curiosity and hinting at the possibility of exotic chemistry or even life. Voyager couldn't see through Titan's thick orange haze, but it did manage to analyze the moon's atmosphere. What it found was surprising. Titan's atmosphere is primarily composed of nitrogen, much like Earth's. This discovery laid the groundwork for Cassini-Huygens' mission, launched decades later, which eventually revealed lakes and rivers of liquid methane on Titan's surface. After completing its planetary tour with a visit to Saturn, NASA faced a decision regarding Voyager 1's next destination. Send it to Pluto, then still considered the ninth planet, or direct it upward, out of the plane of the solar system, to begin its journey toward interstellar space. NASA chose the latter. Voyager 2, meanwhile, continued on to explore Uranus and Neptune. As Voyager 1 left Saturn behind, it turned its camera back toward the planets for one final glimpse. In February 1990, at Carl Sagan's suggestion, it captured a series of images, including the iconic pale blue photograph. Earth, a tiny speck of blue suspended in a sunbeam, seen from 3.7 billion miles away. Sagan's reflections on this image became one of the most profound meditations ever written on humanity's place in the cosmos. Afterward, NASA powered down Voyager's cameras to conserve energy. The spacecraft entered deep space, blind, yet still sensing, still listening, and still transmitting data from the void between the stars. Attached to each Voyager spacecraft is a 12-inch gold-plated copper disc, a time capsule known as a golden record, designed to tell the story of Earth to any intelligent life that might someday discover it. The story of how this record came to be is nearly as compelling as the mission itself. NASA gave Carl Sagan and his team just 6 weeks to decide what to include, a mere month and a half to summarize all of human existence. Working tirelessly, they debated intensely about what sounds, images, and music should represent humanity. The final product is stunning in its diversity. Greetings in 55 languages, ranging from a 6,000-year-old Sumerian language to a Chinese dialect called Wu, sound of earth, thunderstorms, volcanoes, bird calls, laughter, a human heartbeat, and music from around the globe, including Bach's Brandenburg Concerto, a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. The record also contains 116 images encoded in analog format, diagrams of mathematical concepts, depictions of DNA, photographs of Earth's landscapes, and scenes from daily human life. There are also recorded messages from then U.S. President Jimmy Carter and UN Secretary-General Kurt Waldheim. Engraved on the cover is a diagram explaining how to play the record, along with a pulsar map showing Earth's location in the galaxy. The golden records are designed to last for billions of years, likely outliving Earth itself. The odds of an alien civilization ever finding one are astronomically low. Voyager 1, for instance, will pass within 1.7 light-years of the star AC plus 79, 38888 in about 40,000 years. But even that is still unimaginably distant. Yet, that wasn't the point. As Sagan said, the record was a symbolic gesture, a way of saying, we made it this far. We hope you exist. There's something deeply moving about these records, still drifting outward, carrying whale songs, footsteps, and the laughter of children into the infinite dark. They embody humanity at its most hopeful and visionary, the same spirit that created the Voyager mission itself. But what if the golden record isn't our first message to be heard? What if something out there has already taken an interest in Voyager? After its encounters with Jupiter and Saturn, Voyager 1 entered a long, quiet phase known to mission engineers as the cruise fade, an uneventful drift through the vast outer solar system. With no more planets to photograph, public attention faded. NASA shifted its focus to newer missions like the Hubble Space Telescope and Mars rovers. But Voyager kept going, traveling nearly 1 million miles per day, slowly approaching the boundary of our solar system, wherever that boundary might be. Even scientists weren't entirely sure. What they did know was that the sun blows a constant stream of charged particles, the solar wind, that forms a protective bubble around our solar system called a heliosphere. A steady stream of charged particles flowing from the sun, the solar wind, pushes against the interstellar medium, forming a vast protective bubble known as a heliosphere. For decades, scientists were unsure just how large this bubble was or what lay beyond its boundaries. During these quiet, uncertain years, Voyager 1 continued to send back vital data from the outer edges of the solar system. It tracked how the solar wind evolved with distance, charted magnetic field lines, and detected cosmic rays, high-energy particles originating from beyond our solar system. This invaluable information helped refine scientific models of how our sun interacts with the space beyond. Life aboard Voyager, however, was a constant struggle against time and decay. Its power source, a nuclear generator fueled by decaying plutonium-238, loses about 4 watts of output each year. Engineers face difficult choices about which instruments to keep running and which to permanently shut down. The spacecraft's cameras were turned off in 1990, and one by one, other instruments followed as energy became scarcer. As Voyager 1 journeyed farther from Earth, communication became increasingly challenging. Its signal grew so weak that only NASA's largest deep space network antennas could detect it. By the 2000s, a single radio transmission took over 14 hours to reach Earth, traveling at the speed of light. Yet the spacecraft pressed on, venturing into a region no probe had ever explored, the boundary between the solar system and the cold, uncharted expanse beyond. In 2012, Voyager 1 crossed the heliopause, the outer edge of the sun's influence, and entered interstellar space, becoming the first human-made object to do so. It marked the beginning of a new chapter in space exploration. The data it returned revealed a radically different environment filled with galactic cosmic rays and magnetic fields unlike those inside the heliosphere. But even as it drifted farther into the unknown, Voyager 1 began transmitting something unexpected. Strange signal anomalies that puzzled scientists. These weren't ordinary glitches. Engineers at NASA's Jet Propulsion Laboratory first suspected aging hardware or interference from decades of cosmic radiation. However, the patterns didn't align with any known system failures or background noise. Instead, these anomalies manifested as bursts of regular pulses, and occasionally as sequences that seemed deliberately encoded, defying easy explanation. Some scientists propose that Voyager might be picking up unknown cosmic phenomena, such as pulsars or exotic particles, in the interstellar medium. Others entertained a more provocative theory, that the probe could be receiving signals from an alien source somewhere nearby in space. While the idea of extraterrestrial communication remains speculative and controversial, it has captured imaginations around the world. Could Voyager, humanity's most distant ambassador, have become a beacon or receiver for intelligent life? Meanwhile, Voyager 1 continues its silent voyage, hurtling through the cosmos at about 38,000 miles per hour. It now travels through the local interstellar cloud, a sparse region of space filled with diffuse gas and dust. Surrounding the probe is a near-perfect vacuum, temperatures approaching absolute zero, and a quiet hum of radiation from distant stars. Nearly 50 years after launch, Voyager 1 still whispers back to Earth on the edge of the unknown, a reminder that humanity's journey to explore, question, and understand the universe is far from over.